Hello, dear students. I Abhinav Negi and Ashwar Sir welcome you all on Resultant. So, guys, we both are from IIT Delhi. We both have done our MTech from geotechnical engineering, and of course, we both simultaneously will not be teaching you, but at different part of time, different topics will be teaching you. Right now, I will be teaching you the triaxial test. What are the different types of triaxial tests? At what time? At what condition we use? What type of test? When CD is used? When UU is used, everything I'll be telling you in this conceptual session. Over to Sir.
Hello everyone, I hope your preparation is going great. So my dear friends, Abhinav Sir is here for you and he will be taking triaxial test for you. It is a part of shear strength of soil and it is one of the most conceptual topic in your geotechnical engineering. If you ask me what are the various conceptual topic in geotechnical engineering, then I would like to keep this topic shear strength of soil at number one. Obviously, passive pressure, active pressure, retaining theories, and all those are also important. Permeability, effective stress is also very important. But shear strength of soil, believe me, it is one of the most conceptual topic in which your various concepts are being involved, including your strength of material, Mohr circle, transformation of stresses, and all. Okay, what test to take, when to take which test, for what kind, different kind of soil, what are the various type of testing that can be done, and what are the tests which are suitable on grounds and on laboratories. So all these things will be discussed with you in depth by Abhinav sir. So over to you, Abhinav sir.
Okay, guys, just wait. ये अटक रहा है. Okay, just we are checking the buffering is happening. So we are checking that, guys, in couple of minutes. एक बार स्टॉप स्ट्रीम करके वापस से स्टार्ट स्ट्रीम कर. Okay, just wait. We are fixing the issue. Then we are okay, guys. Uh, let me check it again. Let me check it again, guys. वहाँ से कर देते हैं यूट्यूब लाइव फिर. Is it? Hello, 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 hello. Okay, 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 guys. Let me check now. अब सही है क्या? हाँ, अब सही है.
Hang कर सकते. ठीक ठीक. ओके ओके सर, पढ़ा लोगे या
ओके, पढ़ा लूँगा. ठीक है. Okay, guys. So we'll be starting triaxial test. We have fixed the issue, and I hope now the issue will not be coming again. Okay, okay. I guess now it's fine, na? Now, my friends, please let me know audio video. So we'll be starting triaxial test. We have fixed the issue, and I hope now. Yeah, now it's looking fine. Now it's looking fine. Okay. Okay. So let us start triaxial test. Let me again tell you, I'll be teaching you all types of tests and at what condition what test is used. Okay, those who are watching me for the first time, let me introduce myself. My name is Abhinav Negi. I have done my MTech from IIT Delhi. Okay, I have 14 plus years of teaching experience. I got my 164 rank in GATE in 2012. You have to score a better rank than this. You can join my Telegram group, Civil by Abhinav Sir, or you can mail me at abhinav@resultant.in. If you want to WhatsApp me, you can WhatsApp me at 93549 16360. Okay, so now guys, moving forward, yeah, this is the triaxial test, and let me explain you the test here, and again after that I'll be teaching you the various types of triaxial test. Okay Dinesh, thank you, and please in between if it buffers again, please let me know again. Okay, okay champ. Okay, so guys, this is a triaxial cell. What are the various things in this? Let me tell you. First of all, guys, this is the soil sample. Okay, this is the soil sample. We want to find out the C and phi, cohesion and friction angle for this soil. Why we want to find out the C and phi? Because when we will be finding the C and phi, cohesion and friction angle, then only we can find out the shear strength. C plus sigma 10 phi. Then only we will be able to find out the shear strength of that soil. Okay, for finding out the shear strength, we should be knowing the C and phi. One more thing, guys, I want to tell you all that C and phi are not the inherent properties of soil. For the same soil, for the different types of test, C and phi can be different. I repeat, for the same soil, for different types of test, C and phi can be different. Okay, so what type of test we have to use? What type of test we have to use? We have to use that type of test whatever is the field conditions there. So we can simulate the field condition. So we can simulate the field condition. So whatever the things are there in the field, whatever the conditions are there in the field, same types of condition we will be applying in lab, so we can get the C phi. So we can get the C phi. What actually the C phi is in the field, we will be getting the same C phi. Got it everyone? Give me yes or no in the comment section. Dinesh, now audio video is fine. Okay. Now this is soil. This can be having a different values of C phi for different types of testing. So we will be applying the same conditions in the lab that is in the field, so we can get a relatable C and phi. Okay, my voice is okay. So this is the soil sample, this is the triaxial cell, and in this soil sample, this is the water. So we are putting it in the water. Sometimes engine oil and other types of fluids are also applied. Like in IIT Delhi, in my geotech lab, water is used, but in rock mechanics lab, a different fluid like engine oil is used. Okay, so now the soil is this soil. Let me make it here now. This soil is now put up by hydrostatic stresses from all around. Okay, so this is the sigma 3, this is the sigma 3, this is the sigma 3. From all around, due to this water, the confining stress, sigma 3 is also sigma c, the confining stress is applied. Okay, this is the sigma 3, that is the confining stress from all around. Suppose this is a soil sample, this orange one, and in this orange one I am applying sigma 3 from here, sigma 3 from here, sigma 3 from here, sigma 3 from here, from the water. Okay, sigma 3 from here, sigma 3 from here, sigma 3 from here, sigma 3 from here, I am applying. Okay, so this soil is now confined. Okay, from all around, from all directions. And this sigma 3 is coming from this water or cell pressure. Okay, so this is the triaxial cell, Confining stress is applied from water. Now this soil sample na, from all around. This soil sample is put, the rubber membrane is put on this. This rubber membrane is put from all around, whereas this is the rubber membrane. And porous stones are applied at top and bottom. Porous stones are applied at top and bottom. Now, why this rubber membrane and why this porous stones? Because, friends, we want to simulate the field conditions. And in field, we assume soil to be semi-infinite. You always heard that sand is of 3 meter, clay is of 2 meter, water table is at 7 meter below. You never heard that clay is for 100 kilometers square or 50 kilometers square. You never heard that water table is 17 meter below for 300 kilometers. So in this direction, in horizontal direction, soil is infinite. We assume it to be infinite, and we only measure the depths. So in vertical direction, we are measuring the things, not in the horizontal direction. So soil is semi-infinite. Also in consolidation, the water movement is only in the vertical direction. We assume the water to be one dimensional, all water which is coming out in one direction, nothing in x direction. So same conditions are applied from these porous stones. When we apply the stress, water can go above and below, but not in horizontal. Therefore, rubber membrane is applied. So we are simulating the field conditions. Water should be only moving in vertical direction with the help of porous stone, not in horizontal direction. Rubber membrane will be restricting it. There is a proving ring, there is a dial gauge. Proving ring and dial gauge both are identical. Looking like similar, like of twin sisters. Okay, there is a dial gauge and there is a round shape and there is a needle there. The only difference is proving ring is used to measure load or stress, and dial gauge is used to measure deflection or strain. Okay, so now up to now we are applying the stress sigma 3 from all around, and now we want to break the sample. We want to check its strength. So from top we are applying the deviating stress. From top we are applying the deviating stress now. This is sigma d. Sigma d in vertical direction. So finally, how this soil will be looking in the first stage. In the first stage, we are only putting sigma 3. In the first stage, this is the first stage, only putting sigma 3. In second stage, apart from sigma 3, in the vertical direction, we are applying the deviating stress also, sigma d. Okay, so finally, how this will be looking? See here, this is soil, this is sigma 3, this is sigma 3, this is sigma 3, and in this direction, sigma 3 plus sigma d is sigma 1. Sigma 3 plus sigma d is sigma 1. Got it? So sigma 1 is now major principal stress. Sigma 1 is now major principal stress. Major principal stress, and sigma 3 is minor principal stress. So we apply, first of all, we apply sigma 3 from all directions. Then in vertical direction only we apply sigma d, and sigma 3 plus sigma d, this sigma 3 plus sigma d is equal to sigma 1. This sigma 3 plus sigma d is equal to sigma 1. This is the final stage, and for the it is not appropriate to say it the weakest plane, but on the plane where shear stress is more and shear strength is less, it will be failed. Failure may not be at the weakest plane, it can be at different plane. Why? Because might be which is the weakest plane, the strength there is the weakest, but stress is also the weakest, stress is also lesser than the strength. So might be the failure is not there. Let me tell you. Suppose these are the 5 persons. Okay. Suppose these are the 5 persons. 1, 2, 3, 4. And this second one is the weakest. And for hitting them, for boxing with them or a match with them, the players coming there are this one. Here the players which is beating this is this one. For this player it is this one. For this player it is this one. For this player it is this one. So might be this is the weakest, but the person who is having a fight with him is also even smaller. So might be he will win, and any other player who is stronger than this will be losing the match because the contender, the opponent is stronger here. Similarly in soil, might be the weakest plane is not the failure plane, because in the weakest plane the stress is not coming much. Okay, and any other plane might be the stress is more than the strength of that plane, so might be the failure in that plane also. So this is the first stage when I am applying sigma 3 from all around, and this is I am applying the deviatic stress from the top, and finally it is looking like this. Now if I draw the Mohr circle for this, where is the remote? Okay, if I draw the Mohr circle for this, okay, so this is the normal stress, this is the shear stress, and this is the Mohr circle. This is sigma 1, which is sigma 3 plus sigma d. This is the sigma 3, and this is the stress. This is the stress. What all these points are denoting you? These are the stress at different planes. These are the stress at different planes. These are the stresses at different planes. Okay, how many planes are here? How many planes are there? There are the infinite planes, na? There are the infinite planes, na? So infinite planes will be having the infinite normal stress and shear stress. All those infinite normal stress and shear stress, are represented by these points. Every point will be having a x coordinate and y coordinate, na? X coordinate will be normal stress and y coordinate will be shear stress. So all those planes will be having different values of normal stress and shear stress that are represented by this. These are the stresses at various planes. And what is the strength? Strength is shear strength, let me represent it with green color, is C plus sigma tan phi. Okay, it is C plus sigma tan phi. So stress will be C plus sigma tan phi. This is the first experiment we have done for a sample. Sigma 3 of first, sigma 3 first, and sigma 1 of first experiment. Now again the second experiment is done up to failure. So this is the sigma 3 2, sigma 3 2, sigma 3 of second experiment, and now here it will be sigma 1 2. Okay, major stress for second experiment. Now we draw the common tangent. For first of all we make one sample. And find the sigma 3 and sigma 1. Sigma 3 and sigma 1 corresponding to failure. Now another sample is made for the same soil, and we find for the second sample sigma 3 and sigma 1 for the same sample but second experiment. Now draw the common tangent. Now from here draw the common tangent. This common tangent gives the strength C plus sigma tan phi. Okay, so if you compare this with y is equal to, this is x, this is m plus c. So this is the intercept. This will be giving you the value of cohesion, and this angle from slope tan phi is the slope. So this angle will be giving you the phi. This is how we find the C phi. This is how we find the C phi of the soil. Okay, got it everyone? Got it everyone? This is how we found out the cohesion and friction angle. This is how we find out the cohesion and friction angle. Okay, we do two experiments. We perform two experiments. Find the sigma 3 1 and sigma 1 1 for the first experiment, and for the second experiment we find sigma 3 2 and sigma 1 2. From those we draw the common tangent, and from common tangent we get the c and phi, and this is the strength. This is the strength equation. Now see, the maximum shear stress will be here for the first soil, but failure is not at the maximum shear stress. Failure is not the maximum shear stress. Failure is here. Why? Because where there is tau max, the strength is even more. Where there is tau max, maximum shear stress, strength is even more. Similarly here for this second sample, tau max is here, but failure is not here. Failure is here because at this point the strength is even more. Got it, everyone? Got it, everyone? Please let me know. Please let me know. Okay. Now, I'm again telling you that for the same soil, C phi can be different, depends on the type of test we used. Okay, for the same soil, the C phi can be different. For the same soil, the C phi can be different. So what type of test we will be using? We will be using the same type of test that is occurring in the field. The same type of situations we will be applying that is occurring in the field. Okay. Now, why triaxial test is universal test? Because you can find this also and you can do this also. C plus effective stress. You can measure the pore water pressure also. There is a piezometer. From here you can measure the piezometer also. So you can work on total stress also, you can work on effective stress also. You can work on total stress also, you can work on effective stress parameters also. And here, why triaxial is uniform? Because first of all, you are not like direct shear test na, if you remember, the direct shear test, Mohammed Hassan, now the voice is fine na. Direct shear test, the apparatus is such that that the failure will be in a particular predefined plane. If you have seen direct shear test, in direct shear test, the apparatus is such that the apparatus, one soil sample is here, one soil sample is here, and it is shearing like this. We are shearing the same soil sample like this. So failure will have to be here. Failure will have to be here because you are shearing like this. But here, whatever the plane where the stress is more and strength is less, that will be the failure plane. We are not predetermining or predefining the failure plane here. Whatever the plane that has to be failed will be failing here. Okay. Now, guys, here we can test any condition in which water is allowed to move out. That is the consolidated test, and we can do the test in which the water is not allowed to move out. Such that, suppose this valve is open. So whatever the stress we are applying on the soil, the water can go out. That means we are performing the consolidated test. Because we have put the valve open, whatever the load we are applying, the water can go out. That is the consolidated test. Suppose we have put the valve closed. So whatever stress we are applying, we are not allowing the water to move out. So that we are doing the unconsolidated test. Okay. So for the same soil, we can do consolidation also, and for the same soil, we can do unconsolidation also. If we put the valve open, water will go out. If you put the valve closed, water will not go out. Agree? Okay, that is why it is called universal, because we can work in total stress parameter also, we can work on effective stress parameters also. For the same experiment, for the same soil, we can do consolidation also, we can do unconsolidation also. Now, based on this, we have the conditions that in the first stage, what is the first stage? When we are applying the sigma 3. What is the first stage? When we are applying sigma 3. What is the second stage? When we are applying sigma 3 and sigma 1. What is the second stage? When we are applying sigma 3 and sigma 1. Okay, this is the first stage when we are applying the sigma 3 only. Second stage when we apply David stress also, now it becomes sigma 1. Now it becomes sigma 1. Okay, now in the first stage drainage is allowed by putting the wall open. In the first stage drainage will not be allowed if we put the wall closed. Now if we have to make wall open or closed, that depends on the field condition. That depends on the field condition. Okay, now for the second stage, volume change is allowed. Volume change allowed means drain valve is open. Wall is open, so water can go out. Okay, same like consolidation. It is nothing but same like consolidation. And volume change not allowed. Volume change not allowed if valve is closed in the second stage. So whatever time, either the first stage or the second stage, whatever the time, either the first stage or the second stage, anything, we can put the wall open, so we can allow consolidation or volume change allowed, or whatever the first stage and second stage, we can put the wall closed so that it is unconsolidated, or we can say volume change not allowed. So on basis of this, we get three types of test. One is CD test, consolidation drain test, CU test, and UU test. There is no UC test because UC test results are same like CD test. Why it is, that I will be telling you later. In this link only, in this video only, I will be telling you this later. So first of all, consolidated drain test, CD test, consolidated drain test. Now see, I want to find out the C phi. It will be taking a long time because we are allowing the water to go out now. So it will be taking a long time. It will be taking. Okay. So, guys, when I will be doing the CD test? Can anyone tell me? When I will be doing CD test? Anyone? Tell me. Now let me tell you. Suppose a building which is constructed in 1950s. 70 years has been passed. That soil, that building where 70 years has been passed now, that building is in some soil. So in that building, due to that load, consolidation has already happened. Consolidation mostly occurs in 5 years, 10 years, 15 years. So if it is 70 years, due to that load of building, the consolidation has already taken place. So to simulate the field condition of that soil, we will be using CD test because consolidation and drainage that there has occurred. So for the long time testing, we will be using CD test. Now guys, if the construction is done very rapid, and just after the construction you want to test, then you will be doing the UU test. That means in the first stage, consolidation not allowed. In second stage also, volume change not allowed. So you can get the results here very fast. UU testing. Okay, in first stage also, the volume change or consolidation not allowed. In second stage also, volume change not allowed. Where it is used in a long time testing. Suppose the building has lived for 70 years. Now the consolidation has been happened in the site, so we'll be using this. Now if there is fast construction and just after the construction we want to find out the C phi, then we will be using this UU test, because consolidation is not happened in few days there. Okay, in UU test now, I want to tell you one thing, that in UU test, both samples are of same size. Usually, the second sample is of bigger size. Why? Because when you are holding the soil with bigger sigma 3 confining, मैं नहीं जाने दूंगा, When you are holding with bigger sigma 3 than the first, we are holding with bigger sigma 3 from the first, then a bigger stress has to be applied sigma deviator in the vertical direction to break it. A bigger value is applied. Usually the second circle is bigger, but here both circles are of same size because the interaction between the particles is not changing. The interaction between the particles is not changing. Guys, this effective stress is sigma minus u. Here, as if compared to here, in this case, we are applying a bigger stress. We are applying a bigger stress. But how much bigger sigma we are applying? By the same amount, the pore water pressure is also increasing. And it is unconsolidated. You are not allowing the water to go out. So sigma bar remains same. Sigma bar means the strength between the particles, the interaction between the particles. So even if you are increasing sigma, because u is also increased and you are not allowing it to dissipate, so sigma bar will be same. And if sigma bar will be same, so strength between the particles, the interaction between the particles is same. And due to the same strength between the particles, if earlier in the first experiment, it is failing with sigma d difference of sigma 3 and sigma 1, then in the second also it will be failing with the same increment of stress. Therefore the both mode circle will be same, and here the common tangent will be like this, for which phi is equal to 0 and this will be C. So this simulates the clay because clay has C and phi 0. So this is done. This is done. Now I'm telling about this CU test, consolidation undrained test. That means in first stage, in first stage, consolidation is allowed. In first stage, consolidation is allowed. You're allowing the water to go down, but in second stage, you are not allowing. Where it is done? Now let me tell you guys of Qutub Minar. There are many stories in Qutub Minar. And in reality, guys, few years back, the top two stories are fallen down. That means Qutub Minar is applying some load on the soil at the bottom. So consolidation is happening, but suddenly when load is decreased, because the top two floors are gone down, so suddenly the load is decreased. So load is decreased. At that point of time, the water will not go out because you are applying the load, water is coming out, and suddenly you have reduced the load. So at that time, when you are reducing the load, water will not come out. So at that time, it will be unconsolidated. I'm again telling, suppose you have applied the load, consolidation is happening, and suddenly you remove 2 meters of soil. So you remove the load. So at that time, it will be undrained. So for that instance, you will be doing the CU test. For that instance, you will be doing the CU test. Now, why there is no UC test? Because in unconsolidated and after that UD test and then drain test. That is ultimately the water is going out. Now, ultimately at the second stage, you are putting the valve open. First stage is unconsolidated. Second stage is drainage. So in second stage, you are allowing the water to go down. So ultimately the water is going down. So the result will be same like CD, because here is also ultimately the water is going down. Okay. So this video, guys, is I'm restricting myself only about the difference. What is I'm not going into the much deep of triaxial test. I'm not going into the much deep of triaxial test. I'm only telling you what is triaxial test, what are the various types, and where the various types are used. I'm not going into the numericals and much depth and the graphs of various tests. That we can do in some different session. Please let me know in the comment box how you like this video. Okay. Thank you, guys. In resultant, you can connect me at my mobile number. Okay. This is my mobile number, 9354916360. You can mail me at abhinav@resultant.in. You can join our Telegram group, Civil by Abhinav Sir. From the Play Store, you can download the Resultant Civil app. You can just write Resultant Civil. And we have the 1-year course and 2-year course for GATE and ESE. 1-year course is available in Hindi also, English also. 2-year course is also available in Hindi also, English also. So you can, if you want, you can join there. Wish you all the best, guys. Thank you. Take care, and please let me know in the comment section what more videos you want from us. Thank you. Wish you a great day ahead.